Hello, my name's Evan. I've been working on a WebRTC listener that I'd like to show you. This is pure client side. There's no man-in-the-middle WebRTC server. There's no WebSockets, no dynamic HTTP requests, just pure static site, and the WebRTC connections are end-to-end encrypted, browser tab to browser tab. Kind of the characteristics of a listener is you have to be able to bind to an address or listen to an address. You can share that address with multiple people, not just one person. It needs to be valid for multiple connections. You need to be able to detect when people use that address to connect to you, and you need to be able to accept those connections. This does all of those things. I'm going to load it up here so you can see how it works. Here's my address. I'm going to share it with someone. Send some data back and forth. And I'm going to use it multiple times. Same address with two different clients, if you will. So now we get into the long list of caveats. The way this works is that in Chrome, currently, the WebRTC implementation and APIs expose a way of receiving arbitrary data, a small amount, and probably low bandwidth amount of arbitrary data from anyone with your public IP address and port that's allocated. We can send this data from any web browser, as I've shown Chrome here, and we use WebRTC to receive that data here. So you would think that there would be, let's see, maybe 3 RTC peer connections here, 2 in this tab, 1 in this tab, and then 1 in Firefox. But if we actually look at the connections, you'll see there are quite a few more RTC peer connections. Only 2, those other ones were from other tests. And over here in Chrome, we have 5. This is because each page uses 1 RTC peer connection to kind of gather some information about their place in the internet. And then in the case of Chrome, we're using this connection, which is not connected, and this connection, which is also not connected, to detect those incoming connections. So this one says it's connecting, and the reason for that is because it has pure reflexive candidates. Oh, that's the wrong one. That's candidate pair. It has 2 pure reflexive candidates, and these are the 2 incoming connections. This is the arbitrary data that I'm sending. It's in the username fragment, which is only exposed in Chrome currently. And the port is also a useful piece of information. In essence, to connect to this connection, or to this listener, you make a connection to that gathering RTC peer connection, but then I transfer the remote candidate, which is a pure reflexive candidate, from that gatherer to a new answering WebRTC connection. And that's pretty much how it works. In theory, it only works for server reflexive candidates when you have a permissive NAT. But I have been working on building a stateless turn server that generates relay candidates that are actually server reflexive candidates and can only be paired with other relay candidates. It's complicated, but was specifically designed for this use case to make it more reliable. You can find all of the code for the server and also for this demo here. And this is most likely unintended behavior in Chrome. I imagine it's not something that they meant to support, and I don't know, maybe they'll patch it out or remove it, so have fun while it lasts.